what was the very first step? What was the very first thing we had to do? Cross multiply. So multiply the top to everything down here and this to everything down here. How it looks, anytime you have two fractions that equal each other, you're always going to do that. Whether you put this on this side of the equals or on the other side doesn't matter. And then our next step, I mean, go ahead. Distribute everything on both sides. If you jump into the distributing right away, that's okay. If you want to get the hang of it first, that's also fine. Then you have choices. What is something that we moved first? You moved to the other side. Yeah. Okay. If that's not the way you did it, that's okay. Don't erase your stuff. There are 4 different ways you could have gone about doing this. But if you moved v over, now you have to move your constant back. So add 32. And then sometimes you will get decimals or fractions as your answer. If it is a nice fraction or decimal, you can leave it as a decimal. If it's a repeating decimal, just leave it as a fraction. But if you got 23 over 5, or what was it, 4.6, that was correct. Do we have any questions on that one? Some of the other ones that we wanted to see go over. So we'll start with, we had 2, we had 3, we had 5 and 6. And then we're going to go back and do one of the word problems and then move forward. So I mentioned last time that I'm going to show you how to start to do this a little bit faster. Maybe not with 2, maybe not with 3. But instead of moving something once and then moving something, I'm going to have you guys do that at the same time. Now, if you still want to do it one at a time, that's fine. So 2 and 3 don't really count. But our goal is the same. We still need to move the variable to the other side. How you do it doesn't matter, but the more ideal way to do it would be to move 3w over. And then solve from there. So this would end up being a fraction. Now, really quickly, I'm going to show you what would happen if I moved 7w over instead. It changes the way the problem looks. If I move 7w over to 3w, I now have a 0 over there. You can do it this way. It's perfectly fine. You just have also created an extra step for yourself because you still have to move this back. And then still divide. So it can be done either way. You just have to know that you created an extra step if you do it one way versus the other. Do you have any questions on 2? So for 3, how do we think we would solve that one? Dylan?
Minus the 3.3c and then of the 1.3c.
And And then if we subtract that, what do we get? Equals, those cancel, leaving just 2.8. And then we would still divide like normal. So what would C be? Emmett?
-1.4.
So as we just saw in 7, some of our answers can be fractions, can be decimals. Especially if they start with decimals or fractions, you're more than likely going to end up with a fraction or a decimal. Sometimes not. Okay, questions on that one? With 5, what do we think the first step is going to be? Distribute. Even though it has a fraction, we can still distribute. Now, if we ended up with other fractions, it would just make it a little bit more difficult. But more than likely, this fraction is going to disappear. So we're going to have 30m minus 18 equals, what would 24 times 1/3 give us? 8. Because we're really just dividing by 3. And then 12 times 1/3. 4. Okay, so this is where I'm going to show you how to do this just a little bit faster instead of doing it one step at a time. So pick one thing we want to move. Doesn't matter. Jaden. -18. So if we're moving the 18 to the other side, before I finish that, I'm going to also move the other one at the same time. Because I know I have to move 18 over, that means I will also need to move the variable back over. I'm going to do the opposite. It's going to look like this. So it saves a little bit of space on your paper. If you feel more comfortable doing it one step at a time, that's fine. If you feel okay with doing it both at the same time, that's also fine. So then what happens is the 18 cancels, the 8m cancels. On this side, I have 22m. On this side, I just have 22. So it skips some of the steps. We still distributed. We didn't have like terms to combine. We moved. By adding or subtracting, we just did it twice at the same time. And then divide. Do we have any questions on that process, how we got that answer? And then for 6, what would be our first step? I mean, go ahead. Because we have a proportion, 2 fractions that equal each other. So that would be 8 times n plus 8 and 7 times n plus 10. Distribute. And then, same thing, we're going to do this at the same time. Pick one thing you want to move to the other side. Doesn't matter. I heard the 8 before the 7, but if you want to move the 7 first, that's fine. I personally like moving things so it stays positive, but it doesn't matter. So if we move the 8 over, I would also need to get rid of the 70 at the same time. So the 8 n's would cancel, the 70's would cancel. What would we have left? 6 equals negative n. So what would we divide to get n by itself? Mm-hmm. If you had did it the other way, you would already end up with a positive, so you wouldn't need to do this process. 6, not 1. Any questions on that one? We are going to move forward in this, but I want to go back first, just so we touch on this. Take out your other set of notes, the very first set of solving equation notes, and go back to the number 4 on the word problems. The number 8, we're just going to disregard that one. Correct me if I'm wrong. We set this up, but we didn't solve it. Yes. Tell me what the equation was. Minus what? 12. So now that we know how to solve equations with variables on both sides, we can go back and solve this. And we're going to do it again at the same time. So what do we want to move first? The S by itself, okay. So if I'm subtracting this S over here, what needs to be moved to the other side? The 12. So 2s minus s would give us 1s. The 12s would cancel. And then we have equals 19. So it gave us what our s is, our smaller number. Now we just have to find our larger number. Say that again. You could do this or this. Doesn't matter. I'm going to choose this one because it'd probably be a little faster. So whatever that is will equal RL. What is RL? 26. If I put it into this side, the 2s minus 12, the 38 you found would be right for this part, but we still have to subtract 12. So you have part of it, just not the rest of it. So then our two answers would be 19 and 26. Questions on that? Of 2 numbers is twice. I may have wrote it down wrong. The larger of 2 numbers is twice the small number. So L equals 2S. And then 12 is subtracted from the larger number. So this is the larger number. Subtracted 12. The result is 7 more than the small number. So this was the right equation. We subtracted the 12 from the equation of the larger number. That's where that 2s came from. So the first part says the larger of the two numbers is twice the smaller number. So we multiply 2 times the smaller number to get the larger number. And then because 12 is being subtracted from that, we're subtracting 12 from the equation. There's just a lot of pieces and parts that make more sense. Okay. Any other questions on that one? All right, we're going to switch papers again. And then move on to the page that says special cases. There's like, it's blacked out on part of it. Yeah, that page. So we talked a lot about equations that have one solution, where you get x equals something, or whatever the variable is equals something at the end. This is a little different. So we're going to solve 1 and 2, and then see what happens. So for 1, start solving like normal. Distribute. What would we do next? Combine like terms on the same side, so just the 15x and the negative 10x on this side. Before we keep going, look at the equation. What do you notice? Dylan? Okay. We're going to talk about why that is here in a second. Anything else you notice? Any similarities, any differences? They both have the same coefficient before x. That's going to be important. What about differences? The 5 and the 12. So they have different constants. That's also going to be important. So let's solve this, and then we'll come back and talk about all those similarities and differences. So if we are doing things at the same time, and I subtract 5x, just like Dylan said, they would cancel each other out on both sides, so you wouldn't have any variables left. On this side, we have nothing, just 0, and on this side, we have negative 17. Is this a true statement? Does 0 equal negative 17? No. So anytime you get this, where your variables cancel, and you have two different numbers, this is no solution. And then this part that was blacked out, you can write this. You can summarize if you want. There's no possible number that could work as a solution to the equation. That may actually be at the top as well. I don't remember. Yeah, so you don't have to write it because it's at the top, but if you want it in your own handwriting, you can. So that means if we were trying to check this to see if it worked, I couldn't put any number in and no number would ever work. 1 wouldn't work, 10 wouldn't work, any of the negatives wouldn't work. No number I put in would ever work. Nothing would ever work, so this would be no solution. That would be the answer you give. Now, you could get no solution by accident, so you have to be careful. One way you could tell without solving it completely is the similarities and differences we were talking about earlier. If you see that these are the same, the coefficients. Let me highlight. If these are the same, but these are different, you will always end up with a no solution. So at that point in the equation, when you see that, if you recognize this is going to be no solution, you don't have to continue to do the work. But if you forget, then still do the work. I do want to also show you one other thing. So you're either going to get 0 equals a different number, or you're going to get 2 different numbers. If you got 2 different numbers, you would not be doing it simultaneously. So I'm going to rewrite this really fast. You don't have to do this, but if you are doing it one at a time, I would say write this down. So let's say I just moved the x's and nothing else. You end up with 2 different numbers, 5 and negative 12. The rule still applies. This is not a true statement. This is still no solution no matter what. But these are the 2 types of things you might see. Before we do the other case, do we have any questions about no solution? Let's try number 2. Start to distribute just like normal. Combine your like terms on the same side. And then before we continue, I'm going to ask for what you notice again. Jaden.
If we did anything, it would just be 0 equals 0.
Okay, so if we solved it, got rid of everything on both sides, we get 0 equals 0, and we'll talk about that in a second. Anyone else notice anything else? Any similarities, any differences, Regina?
They both have the same, they both have like 6 B's and
They're both the same on both sides. So not just the coefficient, but also the constant. Everything is the same. They're identical. That's going to be important too. Alright, so let's actually solve this. We were doing both at the same time. We would subtract the 6 B's. We would add the 10s. Just like Jaden said, everything is going to cancel, leaving 0 equals 0. Is that a true statement? Yeah. Yes. So when you get something like this, where the variables disappear and you get a true statement, this is called infinitely many solutions. Or IMS for short. And this is like the opposite of no solution. Where no solution, you can't put in any number to ever check to see if it works. But infinitely many, every single number works. 1.5, 100, 100.9, negative a million, all of the numbers that you can ever think of. If you put it into this equation, it will always work. So, earlier when we were talking about similarities, if you see that both sides are identical, everything is the same, you could stop there, say this is IMS, and you don't have to continue solving. If you don't recognize that, you'd have to keep solving. And then just like with the other one, if you were doing this one step at a time instead of both at the same time, and I got rid of my 6 B's, those would cancel, just leaving the negative 10s. But it would still give you a true statement. The same number equals the same number. So no matter how you do it, you'll still get that same thing. So the one concatenate that is a number of solutions for equations, I would say look at them, see if this rule applies, see if they're the same, everything is the same, see if just the constants are different. That'll help you. Or if you don't remember the rule or aren't sure, put them each into Desmos. What'll happen is if it's one solution, it'll graph one line. If it's no solution, it won't graph at all. Trying to remember what happens with infinitely many. I'd have to double check. That one might not graph either. Unless you put them in differently, but I have to double check that one. Do we have any questions on either of these cases? I'm going to have you try a couple. Let's do 5 and 6. Try numbers 5 and 6, and then we'll come back and talk about those. If you finish relatively quickly, check with the people around you, see if they got the same thing. What did we get for 5?
No solution.
No solution. Did everyone get no solution? Yes. Does anyone need to see that one?
No, I was restricted.
Okay. I was going to ask. Okay. And then number 6, what did we get? Infinitely many. Did we all get that? Yes. Does anyone need to see that one? Yes. So for number 6, we would distribute, combine like terms, and if you were using the rule, yes, they're switched, but both sides are the same. You have the same constant, the same coefficient, so you could have stopped here and said this is infinitely many. If not, you could have kept going. Let's say I got rid of just my 3x, then I'd have 6 equals 6. That's a true statement. If I got rid of everything, I'd have 0 equals 0, which is also a true statement. So either way, you should have infinitely many solutions. Correct. Go to the next page. So 1 and 3, if you finish 7 for the warm-up, I asked you to try those. So those I want you'll be working on in class today. And then once you finish them, I'll come around and check. We're going to go through number 2, and then you'll have time to practice. So if you, I'll explain that here in a bit. So let's read number 2 first, either on the board or on your paper with me. Chris has saved twice the number of quarters that Nora saved, plus 6. The number of quarters Chris saved is also 5 times the difference of the number of quarters Nora saved and 3. Write and solve an equation to find the number of quarters they each saved. So, important things. What do you think is important here? Twice the number. Plus 6. 5 times. 5 times the difference. And 3. And then what were you going to say?
Let's go stay at 3.
Okay. There's something else that's really important here. That part doesn't really matter. We do need to know that we're finding both Chris and Nora's amount, so that is important, yes. Not what I had in mind, but yes. Say that again. Because we know we're going to have this all. So it's not number of quarters, it's not their names, it's not that they're saving, it's not solved.
Right.
Fine. Equation. It's not the last sentence at all.
Oh.
It's something in the second sentence.
No, that's also.
Is also.
Yeah.
This is super important because the is usually means equals, but the is also is telling you that whatever the first part is, you're going to set it equal to the second part. That's why I wanted to point that out. So, 1, we need a variable. Does not matter what that variable is. If you want to call it x, that's fine. If you want to call it c or n, that's also fine. Here, doesn't matter. We just have to say what this represents. So what would x represent?
No.
Let's be specific. Number of quarters, but for who? This is just going to be for one of them, not both. But it's not going to be for Chris.
Nora.
It's going to be for Nora. It's the number of quarters Nora saved. So think about it like this. If we knew the number of quarters Nora saved, and then we multiplied it by 2, we would know how much Chris saved. If we knew the number of quarters Nora saved, and then did this math, the 5 times the difference, then we would know the number that Chris saved. So everything depends on Nora's number of quarters. So if you just said number of quarters, yes, but for who? Because that's very specific. Alright, so we defined our variable. Now let's put our equation together. Twice the number plus 6. How would we write that part? Okay. The is also is going to be your equals. 5 times the difference of the number of quarters Nora saved and 3. How would you write that part? Just like that. So then we would need to solve, both for Nora and for Chris. So Nora's is going to get solved here once we figure out what x is, and then you'll have to go back and find Chris. So I'll help you find Nora's, and then you'll do Chris's. So distribute. Start to solve, pick what you want to move. I'm going to move 2x over. If that's not what you want to move, that's fine. And then add 15 to the other side. So we have 21 and 3x. And then divide by 3. So even though I wrote 7 equals x, I'm still going to off to the side, like my final answers, be specific as to what that means. Write it out in words type thing. You're going to figure out how many quarters Chris saved by either putting this 7 into this side, just this side, or putting 7 into this side, just this side. So pick a side, do that, figure out that number. can say, Chris saved 20 quarters. And Nora saved 7. And then for the remainder of class, try problems 1 and 3 if you didn't do that during the warm-up already. If you did, raise your hand and come check it. If you have not started working on the Khan Academy that is due tomorrow, you could be working on that after these. And then after that, if you have something else to work on or want more practice, I can give you that. Or if you have something else to work on tomorrow.